Greetings, mathematicians. Today we're looking at example 2b. We have a fraction divided by a fraction. You can rewrite this with divide sign. So for example, 5c divided by 6d divided by 10 divided by d squared. Those are equivalent to each other. But regardless of either one, we do not divide fractions in math. We multiply by the reciprocal of the second fraction. So the 5c divided by 6d is going to stay there. The divide sign turns to a multiply sign, and I flip the fraction. So d squared divided by 10. And I could have gone straight from here in the original problem here, because here's my 5c over 6d. There's my dividing another fraction, so just multiply it and multiply by the reciprocal. Either way, let's go ahead and continue with this. So 5c, if we were to follow the rules and factor everything out, and even following prime factorization, the numerator would be 5 times c. In the denominator, this 6 I can show as prime factorization 2 times 3 times d. And because I'm multiplying another fraction, I'm going to extend this fraction out, and I'm going to multiply d squared. And I can expand d squared as d times d. 10 in the denominator, that's also going to get multiplied to the denominator over here. I can use the prime factorization 2 times 5. Now I can start simplifying. 5 divided by 5 simplifies to 1 over 1. D divided by d simplifies to 1 over 1. There are no other factors that will simplify. So my final answer in the numerator, c and d, cd, divided by 2 times 3 times 2. So 2 times 3 is 6, 6 times 2 is 12. The final answer is cd divided by 12. And that could have actually been figured out here as well without expanding anything out. For example, 5 divided by 10 is the same thing as 1 over 2. D squared divided by d simplifies to d over 1. And what I have left is 1 times c times d. There's my cd product. And 6 times 1 times 2 gives me 12. So that's how you could do example 2b.